looking at the basic question on Quideo number 3, it informs us that there is a company planning an investment. They're not sure exactly how much profit they're going to make, but they have an idea, and from that idea they create a probability distribution here. So the problem asks us first to find the mean profit, or the expected value as it is called, as well as the standard deviation. So the mean profit can be calculated merely by adding together all of the profits and probabilities individually, and you end up with 3, and that is in millions of dollars. So you end up with an expected, or a mean profit of $3 million. Now for the standard deviation, you just need to plug that into 2 lists on your calculator, use one variable, statistics, and use this the probabilities as your frequency list, and you'll come up with a standard deviation of $2.5199 million from the mean. Part B then asks us, it gives us an equation, which is actually how you convert the return on investment, I guess, into the profit that they actually keep. So they have to give away $200,000 as well as 10% of their profits. So 0.9 times the profit minus 0.2 will give us how much they actually get to retain, and that is again in millions of dollars. So for the mean, you need to multiply that by 0.9, because 10% of it is given away, and then you also need to subtract 0.2, which is $200,000, because again they need to pay that capital fee. So you end up with a mean after paying all the fees they need to pay, the amount they actually retain being $2.5 million. Now for the standard deviation of that net profit, you actually don't need to subtract anything, because if you remember, performing a linear transformation, when you're just adding or subtracting, that has no effect on the standard deviation, because you're not actually stretching or shrinking the graph in any way. So the only thing that's going to have an impact is that factor of 0.9 giving 10% of the profits away, and then we come up with a new standard deviation of $2.2679 million. The advanced question on the Quideo is now discussing an insurance company, and so we're given the annual profit of $150 that it should make, as well as the standard deviation. So our annual profit is expected to be $150, and our standard deviation is $6,000, which you'll notice is very large, especially relative to the expected annual profit. So part A asks us what might contribute to this. So what I've said is that when you're dealing with insurance, pretty much it's hard to predict how much you're gonna make off of each person, because insurance companies make their money off the fact that most people will not get into any sort of accident or any situation which will cause the insurance company to have to pay. So the few accidents that they do get into will be a lot of money that they will have to pay, or conversely, they might make a ton if in someone's entire time on the policy they never have to make the insurance company pay at all. So basically the situations where they do pay, it's just going to be a lot of money, and where they don't pay, they'll be making a lot of money. So that pretty much explains why with insurance you're going to have such a huge standard deviation. So now we're asked that if it writes two of these policies what the mean and standard deviation of the annual profit are. So for the mean, it's fairly simple, just 150, which is what they estimated the mean to be, and you multiply that by 2 because we now have two policies, and that gives us $300 for the mean. Standard deviation's a little more complicated because when you're combining two sets of data, you can't just add the standard deviations together. You need to take the square root of the square of both of them and add those together. And the reason for that is because standard deviation, if you remember how it's calculated in the first place, involves taking the square root. And so this squaring it gets rid of that, and then taking the square root again kind of brings it back to what it should be. So we get about $8,485.28 for that standard deviation, which is still very high, but it's not quite double, which you'll start to see that's where the companies make their money. So the next question asks us, if it writes 10,000 policies now, what will the mean and the standard deviation be? So the mean, again, fairly simple. It's you simply multiply it by that factor of 10,000. So we're looking at about $1.5 million mean profit. But the standard deviation, again, we need to do the sum of the square root of the sum of the squares. So we now have 10,000 standard deviations of 6,000. So if you multiply that and take the square root, we get a standard deviation of 600,000, which you will now note is much less than the mean, which then brings us into part D. Is the company likely to be profitable? So in order to see this, we need to look at the Z-score. So with one policy, your Z-score is going to be so low that pretty much you'll make a profit 50% of the time. But when you have 10,000 now, and we have our new mean and standard deviation, we get a Z-score of negative 2.5, which is very much below the mean. So if they do sign 10,000 policies, the chance that they'll make $0 or no profit is 2.5 standard deviations below the mean, which means that there's a 0.0062 probability that they won't make a profit. So basically most of the time they're gonna be making a profit, and so the probability that they make a profit goes up as the number of policy goes up. So if they do sign 10,000 like it says, yes, they will likely be profitable. But again, if they only have, a couple policies, there's no way to guarantee that they will be. So the AP question describes an experiment for us which aims to test the effect of a newly developed hitch on the draft, which is the energy that's required to pull a tractor through a field. So it starts off by asking us what the response variable is. So if you read the paragraph above, it says that the study was conducted to determine whether a newly developed hitch would be able to reduce draft compared to the standard hitch. So we know that draft is the thing that they are measuring, or kind of hoping to record and see how the hitch affects, so therefore the response variable would be the draft. The next part asks what the treatments are, and the treatments are the types of hitch used. So the standard hitch as well as the new hitch are both different treatments. And finally, the experimental units are the two plots of land, because they're actually having that treatment, the different types of hitch applied to them. Part B then asks pretty much whether the randomization was properly used. given that the goal was to determine the effect of the hitch on draft. So I said yes, the randomization was used because even though there were only two plots, the hitches were randomly assigned to the plots, so there couldn't have been really any selection bias present there. And also the measurement device within the tractor that was measuring draft at 25 different points. Those points were randomly selected. So there's randomization within determining which field was to be used for each hitch, as well as randomization within each individual field, talking about measuring the points. So part C is kind of like part B, but it asks you whether or not replication was properly used in the study rather than randomization. So I said that no, replication wasn't used properly because the treatments were only used once and in two different fields. So there probably should have been more trials performed, both to eliminate confounding variables like the terrain or certain features of the landscape of the plot. And also this would reduce variability within the study because even though 25 different points were used, they were all from the same plot. So without replication, it's really hard to determine whether or not that it was, the hitch that was causing the difference in draft, or if it was the field that might have been partially responsible, which is kind of what D is asking. It mentions that the plot of land is a confounding variable, and to explain why. So I said that because it was used in different plots of land, it's possible that differences in terrain, soil type, and moisture, all things that the draft is dependent upon, was the cause of differences in the response variable, the draft, rather than, the standard or the new hitch when comparing them, because of that lack of replication. So that the lack of replication pretty much makes it so that the plot of land can be a confounding variable, and it's hard to separate, what exactly led to what aspect of the draft changing.